right, so we talked about graphically how to recognize a function and its inverse, or how to determine if a function has an inverse, right, if it passes the vertical and horizontal line test. But here we're going to look at how to find a inverse function graphically, okay? So, or excuse me, how to find it algebraically. So we can, graph the function and use the horizontal line test to determine if it has an inverse function, right? But in terms of algebraically, what we do computationally, if we're given an f of x value, we replace f of x with y, okay, first of all, and then we're going to swap the x and the y in the actual function, okay, and then we're going to solve for y. All right, so originally it would be solved for y, or f of x, right? So we're going to swap the x and the y, and then we're going to solve for y again. So now we're going to basically solve for where x was before, turn that into y, and then solve for y, okay? All right, and then we'll replace y after we find it with f inverse of x in the new function, okay? All right, and then we can verify that they're inverse functions by composing them and seeing that they both come out to x, right? If we put the inverse in for the original, we should see that it comes out to x, and if we put the original into the inverse, we should see that it comes out to x. All right, so let's try that out. Okay, so first let's look at this linear function that we originally start out with, right? And we already know the inverse is x minus 4, but let's see how to find it with those steps that we just looked at, okay? So the first thing we're going to do is we're going to swap, well, first of all, I'm going to put y in here for f of x. Let me just do some color changing here. So that's the first step, is I'm changing, just putting y in for f of x, right? We know that those are interchangeable, those are equivalent. And so the next thing I'm going to do is I'm actually going to swap the x and the y, okay? So wherever there was an x before, I'm going to put a y, and wherever there's a y before, I'm going to put an x, okay? So so what I'm going to do is I'm going to make this x, okay? And then I'm going to make this x, y. Then I'm going to bring everything else down as it was before, okay? All right, and so now what we're going to do is we're going to solve for that y. Okay, so I'm going to get y by itself. So what I'm going to do is I'm going to subtract 4 from both sides. And so we end up with y equals x minus 4. And then I'm just going to flip that around. So y equals x minus 4, right? An equation if a equals b, b equals a, right? So I'm just flipping that around. And then the last thing we're going to do is we're going to put f inverse, that notation, in for y, that y that we just solved for. All right, so those are the steps on how to find the inverse of a function. All right, let's try with another one. This is one that we saw a graph of, and I'll show you the graph again in a minute. But remember, first step, and let me have y'all help me out. So the first step is we're gonna swap f of x with y, right? If we have it, this case, we already had a y, so we didn't have to worry about that. Okay, and then we're gonna swap our x's and our y's, right? And so what I want to do is I want to make this x, and I want to make this y, right? And I'm going to bring down everything else the same. So instead of y equals 2x plus 3, I'm making x equal 2y plus 3, right? Again, we're changing our input and our output, and so that means swapping x and y. And so now we're just gonna solve for y. So I want to get this by itself. So I'm going to subtract 3 from both sides to start. All right, and we end up with x minus 3 equals 2y. And then I need to divide by 2. All right, and so we get y equals x minus 3 divided by 2. And you can leave it like that if you want to. There's a few ways you can write that. I'm just going to rewrite it up here Okay, so one thing we could do is we could distribute the 2 on the bottom. Just like if we're multiplying by 2 and we had x minus 3 in parentheses, we distribute. The same thing happens when you divide something by, by numbers. You can distribute that. So you can make it x over 2 minus 3 over 2. So that's one way to write it. Another way to write it would be to distribute the 2 in front, actually, or make it 1/2 on the outside, because there's an invisible 1 right here, right? So you can make that 1 over 2 and put that in front. So let me write it like that. So it would be 1/2 times x minus 3. So any of those, either of those, any of those 3 ways work, okay? And then again, all we have to do is just swap this y with f inverse of x. And now we're ready to go. So this is the inverse of this original function, right? And remember, we saw the graph earlier. Oh, actually, that's the wrong one. This is the graph that I was looking at. So this is the original function f of x, 2x minus 3. And then this is the inverse, right? This is one of the versions of that we talked about, okay? So before we multiplied the input by 2 and subtracted 3, now what we're doing is we're adding 3 and then multiplying by 1/2, right? Which is the same as dividing by 2. And so we're doing the same operations, but in reverse order. And that's what we're doing the opposite operations in the reverse order. And that's what an inverse does, okay? All right, let me show you an example of a function that doesn't work with an inverse, okay? So here we have a quadratic. We saw the graph of this earlier, and it didn't pass the horizontal line test, but just to kind of show you the how this would play out. First, we're going to change this f of x to a y, right? Bring down everything else. Okay, then we're going to swap our x and our y, so we're going to make this x, and we're going to make the x into y, and bring down everything else, so still square it, and we'll still subtract 1. All right, and now we're going to solve for y. Okay, or we're going to attempt to at least. So we're going to add 1 to both sides. Okay, and so we get x plus 1 on the left, and then we get y squared on the right. And now we're going to take the square root of both sides, right? And here's where it dissolves a little bit, is when we take the square root of both sides, when we're solving algebraically, we need to have a plus or a minus. And that's just not something that that works in this case, because if we end up with y equals the square root of x plus 1, we can't have like plus and minus means 2 different things. It means 2 different values. And so like we need just one value for a function, right? And so this by nature means that we have 2 outputs for whatever the one input is, right? Like if whatever I put in for x, I'm going to have a positive and a negative value of that, right? And so that inherently shows that it's not a function, right? Remember, the square root function we talked about is half of a parabola, like that. And this one would be shifted to the left 1 unit, right? But a square root function doesn't have the bottom part of it for the reason that it wouldn't pass the vertical line test, right? And so square root function only returns what we call the principal values, like the positive values that come out of the square root, not the negative. And that's because that's just what it has to be in order for it to be a function, right? And so you can't have that plus or minus there. And because you can't have the plus or minus there, it's not a true inverse of the original function, right? So if we go back and look at this graph, this one right here, this one here, we can see that if we were to flip this about this line right here, we could get the part of it that's like this, right? But we wouldn't get the part of it that's on the other side of it, because again, it wouldn't pass the vertical line test. All right, so that's an example of a function that doesn't have an inverse, and generally quadratics will not have inverses. All right, and so we've talked about functions and their inverses. We talked about how to evaluate them graphically to pass it by using the horizontal line test, right, to see if a function can have an inverse. And remember, if a function does have an inverse, it's called a one-to-one function. That means it passes the vertical and the horizontal line test. And those types of functions are ones that can have an inverse. And then we also talked about how to find it algebraically by swapping our x and our y and solving for y. And so we were able to do that as well, right? But remember, not every function does have an inverse. And so, yeah, so that's something that works for some functions, but not for others.